In a sheltered cove off the eastern coast of Canada, a modern superstructure takes shape. The heaviest oil platform ever constructed. Designed to survive one of the harshest environments in the world. 80-foot waves, sub-zero temperatures, and multi-million-ton icebergs guard a 3 billion barrel oil field. Many men have died seeking to claim this treasure. Soon, a state-of-the-art oil platform will take to these treacherous waters, hoping to conquer an ocean never before defeated, and become the first superstructure to survive the Grand Banks in a deadly quest for oil. Autumn 1991. Near St. John's, Newfoundland, a massive superstructure sprawls out along the edge of the North Atlantic. Each day, 3,000 workers brave 30-degree temperatures and Arctic winds to complete a monumental task, the construction of the Hibernia GBS. When it's finished, powerful tugs will tow this huge oil rig 200 miles out to sea. There, it will become a city above the waves, the home of 280 workers attempting to extract 615 million barrels of oil from the bottom of the North Atlantic. If those workers are to succeed and survive, engineers must build an oil platform unlike any other. Most oil rigs float on the surface of the sea, but a GBS is a fundamentally different design. GBS stands for Gravity-Based Structure, a colossal concrete tower cemented to the ocean floor. From this concrete base rise 4 360-foot concrete and steel shafts, strong enough to hold a 37,000-ton platform 100 feet above the sea. When finished, this modern technological wonder will stand 735 feet tall and weigh over 1.2 million tons, nearly as tall as the Golden Gate Bridge and 3 times heavier. It will take 7 years to build the Hibernia GBS at a cost of $4.5 billion, 4 times the amount spent on building the world's tallest skyscraper, the Petronas Towers in Malaysia. The giant rig is being designed and built by Canada's Hibernia Corporation, one of the world's largest oil consortiums. The project is so huge that no one construction company can do all the work in 7 years. Building the Hibernia GBS must be a worldwide effort. While Hibernia builds the oil rig's massive concrete base in Newfoundland, construction firms in Italy and South Korea will build the platform's upper structures, giant steel modules where the oil workers will work and live. Seagoing barges will tow the 8,000-ton modules across the oceans for final assembly with the base in Newfoundland. The first challenge facing the builders of the GBS was finding a place to build it. A GBS must be built at the water's edge because moving such a huge structure over land would be impossible. Hibernia Corporation chose a coastal inlet called Bull Arm, 80 miles northwest of St. John's, as the best place to build their giant rig. Bull Arm's channel was deep enough to allow the finished GBS to be towed out to sea, while its tall cliffs and sheltered cove would protect the construction site from Newfoundland's harsh weather. For weeks, crews worked around the clock, transforming Bull Arm into a state-of-the-art construction site. Earth movers had to excavate 9 miles of roads just to reach the Bull Arm area. Huge cranes dredged a dry dock construction site at the water's edge. Bulldozers dumped over 850,000 cubic yards of rock into the ocean to form the protective barriers surrounding the dry dock site. Now, 400 acres of what was once forest have become a small city of 3,000 people. As they begin their task, these engineers and construction workers know that the oil rig they are building at Bull Arm will have to do more than just pump oil. To extract that oil, the Hibernia GBS will have to survive the most dangerous stretch of ocean in the world. Over the years, many sailors have perished battling the fury of the Grand Banks. Located 200 miles southeast of Newfoundland, this legendary body of water is one of the world's most abundant fishing grounds. It's also the final resting spot for more sunken ships than anywhere else in the world. In 1991, these waters produced what meteorologists described as the perfect storm. 100-foot waves, buffeted by 80-mile-per-hour winds, destroyed 2 ships and killed 7 seamen in just one night.
It's a very harsh environment. The wave and the weather are about the same as in the northern North Sea. But in addition to that, we have icebergs.
Million-ton icebergs, and thousands of them. They're feared by mariners who call the Grand Banks Iceberg Alley. Where the tallest iceberg ever recorded, a 550-foot mountain of ice nearly as tall as the Washington Monument once floated. When it's finished, the Hibernia GBS will be towed 200 miles out to sea and anchored to the ocean floor in the heart of the Grand Banks. Just 150 miles south of where the Hibernia GBS will someday stand lies the Grand Banks' most famous victim. Nearly 2 miles below the surface, beautifully preserved in the sub-freezing waters, lies the Titanic. This superstructure was once thought to be indestructible. It's an eerie reminder of what can go wrong when confidence in our engineering prowess goes too far. In his 30 years at sea, Captain Mark Turner has seen all too often the consequences of underestimating the North Atlantic's power.
There's nothing unsinkable. There's nothing infallible, man nor machine. So it's, and we have to accept that fact. And, you know, the Titanic is a good example, but it's reality. We are man, and we're very weak in many ways. We can build whatever we choose to build. However, against Mother Nature, it's a mere toothpick.
Now, 79 years later, the Hibernia's designers know that they must do better than the builders of the Titanic. The GBS must be able to survive the Grand Banks for at least 25 years. Hundreds of lives and billions of dollars are at stake. For beneath these treacherous waters lies a petroleum bonanza. During the early 1970s, marine seismic data and satellite imaging hinted that the Grand Banks might be rich in oil. Geologists suspected that 150 million years ago, the seabed beneath the Grand Banks was a fertile river system teeming with life. As the sea covered the land, layers of sediment buried dead plants and animals. Downward pressure from these layers of rock turned the decaying remains into oil. For 10 years, oil companies drilled hundreds of wells and discovered nothing. Prospecting for oil in this region is like searching for a needle in a haystack. Then, in 1979, the Hibernia Corporation discovered an immense oil field 200 miles off the coast and 12,000 feet below the ocean floor. It would prove to be the 7th largest recoverable petroleum deposit in the world, worth $11 billion to whomever could extract it. For Hibernia, it was the strike of a lifetime.
The Hibernia field is a giant. We have over 3 billion barrels of oil in place. That's 3 billion barrels in the ground. Now, the trick for us as a reservoir team is how do we get that oil out of the ground?
In 1982, Hibernia began exploring the new oil field. But before the drilling could begin, tragedy struck. One of the first exploratory rigs to arrive over the Hibernia field was an enormous platform called the Ocean Ranger. It stood 340 feet tall, with an upper deck the size of 2 football fields and a crew of 84 veteran oil workers. Unlike a GBS, the Ocean Ranger was not cemented to the ocean floor. It was designed to float above an undersea oil field, buoyed by 8 huge water tanks called ballasts. Floating rigs had operated safely in some of the world's harshest environments. Ocean Ranger was reputed to be the safest oil rig in the world, designed to survive 110-foot waves and 100-mile-per-hour winds. In heavy seas or high winds, water in the ballast tanks could be transferred from one tank to another to stabilize the platform. For 15 months, the Ocean Ranger successfully withstood the Grand Bank's onslaught of wind, ice, and wave. But on February 15, 1982, the unthinkable suddenly became a reality.
It was cold. It was freezing spray conditions, extreme weather conditions. Sea conditions were between 50 and 60 feet. Everybody was trying to work as best they could, but the weather conditions were just so extreme, it made things close to impossible.
80-mile-an-hour winds and 55-foot waves pounded the 25,000-ton Ocean Ranger. The crew radioed for help. Controllers worked frantically to stabilize the rig as the platform began to list heavily to one side. Emergency crews desperately tried to correct the problem, but the pounding waves made it impossible. The captain issued the order to abandon the rig. 20 minutes passed before the first rescue vessels arrived. The rescuers discovered the platform of the Ocean Ranger floating upside down. The storm's massive waves had flipped the giant rig. For 7 days, search teams looked for survivors. They found none. Only 22 bodies were recovered. All 84 men aboard the Ocean Ranger had frozen to death in the icy North Atlantic.
We'll never forget about Ocean Ranger here in Newfoundland. Catastrophes such as those, I think, will stay etched in all of our minds.
As they build the Hibernia GBS, the workers are haunted by the terrible fate of the capsized rig. Almost everybody working at Bull Arm lost a friend or relative on the Ocean Ranger. But the disaster has also inspired the designers of the Hibernia GBS to construct the safest platform possible. They know the rig will have to survive 100-foot waves, hurricane-strength winds, and a collision with a 1-million-ton iceberg. The largest iceberg ever recorded, 200 feet taller and 5 times heavier than the Statue of Liberty. Scientists must learn more about the true strength of their icy enemy. They must embark on an unusual journey, an experiment never before attempted. A quest to fathom the power of the ice. The construction of the Hibernia GBS has united American and Canadian oil companies in an historic alliance. Together with the Canadian government, they're investing over $4 billion in a search to understand the power of icebergs and construct the world's safest oil rig. The world's first oil platform capable of withstanding a collision with a massive iceberg. From January to June, any ship navigating the Grand Banks must steer clear of icebergs, something easier said than done. 85% of an iceberg's mass lies hidden beneath the waves. Between 10 and 20,000 form in Greenland and the Canadian Arctic each year. Carried by a strong southern current, almost 1,000 icebergs drift through the North Atlantic. The icebergs begin to melt as they reach the warmer waters of the Grand Banks. But a 1-million-ton berg, the biggest ever seen, could take up to 2 months to disappear completely. Ships can steer clear of icebergs, but the Hibernia GBS can't. Its massive underwater base, the gravity-based structure, is permanently cemented to the ocean's floor. The enormous weight of the GBS will ensure that the Hibernia will never capsize like the Ocean Ranger. But this stability has a price. By making Hibernia immovable, the GBS design virtually assures that the giant rig will someday be rammed by a drifting iceberg.
My fear really is just the unknown of the ice. There are so many unknown variables about it with regards to frequencies, with regards to movement.
Determined to fathom an iceberg's destructive force, scientists from the Center for Cold Ocean Resource Engineering, or CCOR, devise a unique experiment. Never before has the impact of an iceberg been measured in a real environment. Only small samples have been crushed in laboratory experiments. To test the power of moving ice, CCOR scientists decide to ram icebergs into an island.
In the grand scheme of things, it's certainly not a 100,000-ton iceberg. We were talking pieces of maybe 1,000 tons, maybe up to 2,000 tons, something like that, which is still a fair-sized chunk of ice.
Nobody knows for certain how size, speed, and buoyancy will affect the force exerted by an iceberg when it collides with a stationary structure. To measure this, CCOR scientist Greg Crocker and a team of engineers build a 21 by 21 foot panel and attach it to the side of a remote island in northern Newfoundland. Half underwater and half above, this metal panel uses electronic sensors to record the force an iceberg exerts as it strikes the cliff. Only one problem remains: capturing and towing an iceberg into the panel. Crocker and his ice wranglers search for a likely candidate. Their plan is to attach an anchor to a berg and tow it to shore using a strong tugboat. But this proves difficult.
The anchors generally didn't hold. The towing vessel had about a 10-ton pull, and it was enough to essentially pull the anchors out of the ice.
CCOR scientists reevaluate their approach and decide to lasso the iceberg instead. By encircling the berg with a rope connected to the back of a tug, they tow mammoth chunks of ice to their island laboratory and send them crashing into the electronic panel. At first, the results seemed baffling. Sensors in the electronic panel recorded less force from the impacts of giant icebergs than from far smaller ice samples tested in labs. But CCOR scientists think there's a simple explanation. In the wild, icebergs are constantly melting. As they melt, they weaken. Although it looks rock hard, a 100,000-ton iceberg has many weak points within its seemingly solid mass. When a berg of this size collides with a stationary object, its weak points diminish the force of the impact. Since previous laboratory tests had used only small, compacted ice samples, researchers had remained unaware of these critical weaknesses of larger bergs. The CCOR experiments proved for the first time that internal weaknesses significantly diminishes the force of an iceberg's impact.
No one had ever directly measured the forces and pressures that an iceberg exerts on a structure when they interact. And you can calculate on paper what they might be till the cows come home, but there's a lot of confidence built up when you actually have some data which tells you in the real world what those forces are going to be.
The revolutionary results of CCOR's iceberg impact tests reassured Hibernia GBS designers that their platform could survive a collision with a 6 million-ton iceberg. But Crocker warns people of becoming overconfident. After all, 6 million tons of ice could crush an entire city block.
You need to design for a certain ice load and some acceptable level of risk, because you can never reduce risk to zero. We don't try and deny that those risks are there. We try and design structures that are safe within that environment.
Over 30 GBS platforms operate in the North Sea off Scotland and Norway, where icebergs never come. These rigs have tall, slender base frames designed to offer minimal resistance to powerful waves. An iceberg's force would crush them. To extract oil from the Hibernia field, a rig must sit directly in the iceberg's path. The Hibernia's designers must invent a new defense against this deadly threat. They decide to build a huge ice wall surrounding the underwater base of the platform. At first, the ice wall appears to be a disorganized mesh of steel rebar and concrete, but it's actually an intricate plan, inspired by designs which strengthen the foundations of skyscrapers to withstand a magnitude 8.0 earthquake. Following a detailed map, workers place each steel beam in an exact location. These beams will help to reinforce the strength of the concrete. After 69,000 tons of these beams are set in place, workers pour high-strength concrete around them. It's essential that the pouring of the 400,000 tons of concrete be precise. If it dries unevenly, a weak spot can develop, leading to the complete collapse of the Hibernia GBS at sea. A process known as slip forming ensures a perfect pour. Slip forming calls for building a wooden platform around the inside edge of the GBS. Workers pour concrete through holes in the platform and use metal chutes to distribute it evenly around the steel bars. As the concrete dries, a computer raises the wooden platform, creating an even pour. For 3 months, this process continues. The outer walls rise nearly 3 feet per day. Slowly, the revolutionary design of the Hibernia GBS takes shape. 4.5-foot thick walls soar 280 feet high. The jagged outer wall is actually 16 reinforced concrete teeth designed to break apart an iceberg if it collides with the rig. Inside the massive concrete shell, engineers install a 50-foot thick ice belt. This gap between the outer and inner walls of the base will someday be filled with over 550,000 tons of iron ore. When the GBS is in its final position at sea, engineers will pour the iron ore mixed with seawater into the ice belt.
It's a protection for the entire facility. I mean, it's the people, it's the drilling, everything is protected by that ice wall. Everybody always says when you look at that ice wall against an iceberg, we think we'll win.
If an iceberg strikes the Hibernia GBS, the outer teeth will chew away the ice, while the inner ice belt will absorb the iceberg's impact, distributing the force throughout the base. But before the GBS faces icebergs on the open sea, its 5 upper modules must be completed. In these steel homes, the 280 men and women aboard the Hibernia rig will eat, sleep, and work for 3 weeks at a time. They'll face dangers oil riggers never encounter on land. They'll be isolated in the middle of the North Atlantic, 200 miles from the nearest rescue station. Anyone who would dare to live and work in this deadly environment must first undergo a grueling, frightening ordeal. A rite of passage that could make the difference between life and death. 400,000 tons of concrete poured around 90,000 tons of steel, the Hibernia GBS stands ready for battle. Its builders have designed its jagged-edged ice wall to defeat the most powerful icebergs in the Grand Banks. The GBS is so enormous it seems indestructible. But even superstructures are only as good as the people who operate them. Not even cutting-edge technology can guarantee the lives of workers aboard a platform in the middle of the Grand Banks.
It's not an environment in which We are designed to operate as animals ourselves, so the ocean is an unforgiving place to be if you don't take account of what dangers it can present.
In 1982, the Ocean Ranger disaster taught Newfoundland's oil workers the deadly consequences of being unprepared for an emergency. When their rig capsized, the Ocean Ranger's crew panicked. Terrified workers scrambled to lifeboats and jumped into the freezing water. For all, death came quickly.
The temperatures of the Grand Banks can vary to sub-zero, to just above zero. If you are in the water, forget it. You have maybe a minute.
84 men died on Ocean Ranger because they had no idea how to save themselves in an emergency. As a result of that tragedy, all Canadian offshore oil workers must now complete an intensive survival training course before they begin working at sea. The Hibernia Corporation takes the dangers of working in the Grand Banks very seriously. It spends over $2 million each year on survival training. Employees who will operate the Hibernia GBS must undergo a one-week program, the most grueling in the industry. It's an exhausting, often frightening ordeal. Those who fail lose their jobs. The Offshore Survival Training course begins by introducing each student to the survival suit. Designed to keep water out and warmth in, these suits will keep a person afloat in the worst sea conditions. In the North Atlantic, an unprotected swimmer will succumb to hypothermia within 15 minutes. A swimmer wearing a survival suit can survive in 20-degree water for 6 hours. But knowing how to use a survival suit is only a start. Unlike any other survival training in the world, the Hibernia program requires that each student leave the safety of the training pool and experience the cold, brutal reality of the North Atlantic firsthand. Out here, students get a frigid wake-up call.
At sea, you have a different attitude. You realize that, gee, this is the real thing. I have to perform. I have to. Now my training is actually going to surface, and I've got to use that training.
At sea, each student must demonstrate his or her ability to swim in the ocean, jettison life rafts, and board rescue boats. They're taught to work as a team. In the middle of the Grand Banks, teamwork is essential. If one person panics, many may die.
It's better to have a cool mind, appreciate that you work as a team, and that you're as one integral unit. And that way you will survive. You have to think positively. Situations occur. But if you're well trained, you can deal with those situations, and you can save not only your own life, but those of your friends next to you.
To save lives, the Hibernia GBS is equipped with 8 state-of-the-art lifeboats. Each lifeboat is self-contained, motorized, and impossible to capsize. They're designed to survive a storm as powerful as the one that destroyed the Ocean Ranger. But mustering everybody to a lifeboat station and launching the craft takes time. Time offshore oil workers may not have. So the oil platform is equipped with 3 Salantic skyscapes. Located at each lifeboat station, these nylon chutes propel a person 100 feet down to the ocean's surface to a waiting life raft. Using the Salantic skyscapes and the lifeboats, the entire crew can quickly abandon the platform. Unfortunately, a fast evacuation may be necessary. Sitting on top of combustible oil and gas, any oil rig must be prepared for the possibility of a devastating explosion. Tragically, it's happened before. In the early hours of July 6, 1988, the Piper Alpha oil rig in the North Sea exploded. A gas leak ignited an enormous fire which burned for 15 hours. 167 men died, most of them asleep in their beds. The rig was completely destroyed. An inquiry into the Piper Alpha disaster concluded that if its workers had been trained in basic firefighting techniques, they might have survived. Working in the middle of the world's angriest ocean, 200 miles from the nearest fire station, oil riggers aboard the Hibernia GBS will have to fight their own fires. To have any chance against a deadly fire, they must be trained in firefighting. Hibernia's workers are not expected to become expert firefighters. Their training will help them prevent a fire from spreading until professional support arrives, if it arrives in time. The journey to Hibernia's isolated home takes 16 hours by boat, an hour and 30 minutes by helicopter. The platform's most vital link to the mainland is also one of the most dangerous means of air travel. More than once, choppers carrying workers to their oil rigs have crashed into the sea. For this reason, any person who will someday fly to the Hibernia GBS must first pass the most frightening test of all, the helicopter dunk tank.
The helicopter dunk that is the be-all end-all. I think that is the clincher for people. Just the fact of doing several trials of being dipped in a prototype of a helicopter and trying to get out through the window.
On this final day of their safety training, students experience what everyone hopes will never happen. When a helicopter crashes into the sea, there's very little time to react. To survive, passengers must keep calm and know exactly what to do. Immediately, they have to knock the emergency windows out. If the helicopter sinks, the water pressure will make it impossible to open anything. Then they must suppress their overpowering urge to flee and wait, because most helicopters will quickly flip upside down. Only then is it safe to escape.
It's amazing how disoriented you are initially, because, I mean, everything's turning and all of a sudden you're hanging there upside down. And again, it's the training that helps you. And because what you find is they said, as we do this, hold on to the window frame. And so when you're upside down, all of a sudden you realize, hey, there's my window frame, I'm oriented, you pull yourself out the window and you're up to the surface.
Over 3,000 men and women push themselves through the offshore survival training program each year. Most make it, but when some are faced with the sobering reality of what might go wrong, they walk away. 1% of those who begin the survival training program never make it to the end. Even with all the training and all the safety precautions, the risks seem too great. As the final assembly of the Hibernia GBS nears, the specter of the Ocean Ranger tragedy rises once again. If the design of this platform isn't perfect, over 3 times as many lives could be lost.
Lots of things can go wrong, and we work hard to make sure things don't go wrong. Safety is really #1 for us, and I mean, if you don't get that right, all these other things don't matter, because we've got 270 people that call that little platform out in the middle of the North Atlantic home.
Trying to understand how powerful waves can capsize oil rigs, industry investigators decide to recreate the Ocean Ranger disaster. To accomplish this, they turned to the National Research Council of Canada's Institute of Marine Dynamics, or IMD, and its indoor ocean. Nearly as large as a football field, this huge basin holds up to 1.5 million gallons of water. It can accurately recreate the stormiest ocean environment.
We'll put a structure or a ship in the basin, and we can have waves coming from one or more directions, much like the real ocean. And in addition to that, we can superimpose a current on top of that.
Working at a scale of 40:1, Institute engineers build a model of the Ocean Ranger rig and place it in the center of the indoor ocean. Using large metal flaps along the edge of the basin, they create a 1.5-foot wave, the indoor ocean's equivalent of a 60-foot swell. To everyone's surprise, the Ocean Ranger stays afloat. Puzzled by this mystery, investigators look for another possible cause. They listen again to the final communications from the crew of the doomed rig and make a crucial discovery. During the fatal storm, an open porthole in the ballast control room allowed water in, short-circuiting the computers. Without computers, workers couldn't operate the ballast tanks, which could stabilize the rig. As it lost balance, its bow dipped down, perilously close to the ocean's surface. At IMD, scientists recreate this dangerous imbalance using their model of the Ocean Ranger. Then they send a succession of 60-foot waves hurling towards the model. They hit pay dirt. The Ocean Ranger flips.
I think most of the problems with the Ocean Ranger were sort of a combination of incredible bad luck and a lack of training. In fact, the rig was quite stable. It wanted to stay afloat. It was just a combination of an extremely large wave that ultimately flipped the rig over, or an exceptionally poor ballast condition.
The sobering revelations from IMD's investigation strengthen Hibernia's resolve to build the safest oil platform in the world. A rig capable of surviving 100-foot waves in the open seas. The platform must pass one more crucial test, or risk being battered to pieces by the fury of the North Atlantic. From Italy and South Korea, enormous barges arrive off the coast of Newfoundland, transporting the modules that make up the upper platform of the Hibernia oil rig. Each of these 8,000-ton steel compartments weighs 1,000 tons more than the Eiffel Tower. Carefully, workers offload the 5 modules onto a pier and spend 7 months welding and bolting them together. United, the entire topside platform weighs 37,000 tons, standing 370 feet tall. Once mated to the GBS, the Hibernia rig will become a 1.2 million ton superstructure, towering 735 feet from top to bottom. But even an oil rig of this size is destined to receive a battering from the huge swells of the Grand Banks. Over time, repeated blows of powerful waves may fatally damage the rig. To avoid waves constantly crashing into its underside, the platform will hover 100 feet above the ocean's surface. The lives of 300 workers and the success of a $4 billion project rest upon this design strategy. Before they mate the platform to the GBS, engineers need proof that their design will be wave resistant. Once again, they turn to the indoor ocean in St. John's, Newfoundland. Here they will test whether the distance from the bottom of the upper platform to the sea's surface is high enough to prevent waves from battering the platform's underbelly.
It's much better to fail here or find out the events that are going to cause a failure here than it is in real life, of course. I mean, model tests are not cheap, but they're certainly cheaper than the real thing.
The full fury of the Grand Banks is unleashed in miniature. The unique design of the Hibernia GBS sends waves crashing higher than any other oil platform ever has. Engineers are worried. They send 75-foot waves, the largest swells generated by most Atlantic storms, barreling towards the platform. When they strike the enormous base, the waves cascade upward. But the underside of the topside platform remains untouched. The Hibernia GBS defeats the indoor ocean. Reassured that the platform's design will survive the force of even massive waves in the Grand Banks, engineers prepare to connect the topside platform to the sunken base. The mating procedure begins with the flooding of the dry dock construction site and the tow out of the GBS to deeper water 1 mile from shore. There, workers add water to the ballast tanks, lowering the GBS until only 18 feet of the 4 364-foot shafts are above water. They position the platform over the sunken GBS with 2 huge barges. Lining up the 2 structures perfectly, they slowly raise the base to meet the topside platform. The GBS is already in position at the deep water site. Only the positioning of the platform over the base remains. For 48 hours, 5 tugboat captains positioned 2 gigantic barges under the pier holding the 5 modules. They must evenly distribute the weight of the topside platforms across both barges to ensure a safe trip to the sunken GBS. It will take 12 hours to position the topside platform over the base. Precision is essential.
We had to float at something like 2 kilometers, 1.6 or 1.7 kilometers, and then position it within a thumbnail over another structure that's equally as massive, but weighs something like 550,000 tons.
The barges creep towards the sunken base at barely 1.5 miles an hour. They must float to within 20 inches of the connection point. As the topsides reach the GBS, a winch system takes over, connecting the barges to the sunken base, moving the 5 modules into exact position. Engineers carefully check the placement. They believe it's right on the nose and give the order to raise the GBS. Workers pump water out of the GBS ballast tanks. Slowly, the base rises up to meet the topside platform. 5 years after its construction began, the Hibernia GBS oil platform stands as a completed structure. As more water leaves the ballast tanks, the Hibernia platform rises further above the sea, a new giant in the region.
The mating procedures were fantastic. It was an unbelievable feat. And I sincerely believe that, yes, it can certainly last to 15 years or 20 years.
Towering over the coastal cliffs of eastern Newfoundland, the Hibernia GBS seems indestructible. This superstructure of concrete and steel now weighs over 600,000 tons and stands 735 feet, 4 times taller and 10 times heavier than the Titanic. With such weight and height, it would seem that here, finally, is a man-made structure capable of defeating the Grand Banks. But one more challenge remains. The Hibernia GBS must leave the calm, protected waters where it was built. For the first time, the platform will be exposed to the extreme conditions of the North Atlantic's open sea. Only then will its builders know whether they have succeeded or failed. Against the rugged coastline of Newfoundland, the Hibernia GBS stands triumphant, a modern superstructure ready to tackle the harshest ocean in the world. But before the GBS can pump a single barrel of oil, engineers must install it in the middle of the Grand Banks. A 400-mile journey straight through the heart of Iceberg Alley. Before the tow-out can take place, weather conditions must be exactly right. The Hibernia GBS isn't designed to move easily through the water like a ship. Moving it to the Grand Banks will be like towing a 75-story skyscraper out to sea. If strong winds strike en route, the 370-foot tall topside platform will act like a giant sail and could capsize the entire structure. As Hibernia officials monitor the weather, 9 of the most powerful tugs in the world arrive in Bull Arm. They'll guide the platform out of its home of 6 years and into the North Atlantic. Although the Hibernia oil field is only 200 miles from Bull Arm, the GBS must travel twice that far to get there. It will follow the coastline to avoid rough seas and icebergs. Forecasters must predict at least 10 days of clear weather before the tow-out can begin. But day after day, the seas remain too rough for travel. Along the shores of Newfoundland, locals gather to bid adieu to their giant neighbor, only to find it's still at Bull Arm. Hibernia officials can afford to wait. They've budgeted for just such a delay. Finally, after 3 months, the weather clears and the tugs are ready to go. The GBS embarks upon its perilous journey. 6 tugs position themselves in front of the platform. They'll provide the power to pull it forward. Meanwhile, 3 tugs take up positions behind the Hibernia to provide steering, much like a rudder in a small boat. With good weather, calm seas, and a well-mapped course, the Hibernia GBS has no problem navigating out of her protective cove. Traveling at 2 miles per hour, she's able to cover nearly 60 miles per day. But as the platform reaches its final destination, a storm kicks up high seas. Tugboat captains halt the tow-out.
We arrived at the Grand Banks in very good time, but then we had to wait 7 days before we towed it into position because it was very shallow water.
Although they're more than 200 miles offshore, the Grand Banks are not very deep. Beneath them lies North America's continental shelf. Depth in the Grand Banks can be as shallow as 180 feet. Engineers plan to anchor the Hibernia GBS to an underwater peak just 260 feet below the surface. But the oil rig's concrete base extends over 250 feet deep. As the tugboat captains maneuver it into position, there will be only 10 feet of clearance between the GBS and the ocean floor. This will be the most dangerous time of all. Large waves or gusty winds could make the rig bob violently in the water and send it crashing into the seabed. The storm rages for almost a week. The tugs can only wait. Finally, the weather clears. The tugs begin the final phase of the tow-out. For 70 tense hours, tugboat captains carefully maneuver the Hibernia toward a target zone just 33 feet long, no bigger than a semi-trailer truck. Remarkably, they touch down within 5 feet of the center mark. But before celebrating, workers must first lower the Hibernia GBS to the ocean floor and add the solid ballast to the interior ice belt.
This had never been done before. We'd planned a little over a month to do this, and it took us close to 2 months to do this.
Above water, barges carrying 550,000 tons of iron ore begin to transfer the solid ballast to the GBS. Gently, the tower sinks toward the sea floor. As it hits the soft mud below, 120 concrete skirts encircling the underbelly of the GBS penetrate 7 feet into the sand.
The skirt is like a bunch of, almost like a cookie cutter that is pushed into the bottom. And the structure is sitting on the top of the cookie cutter. And then once they're in place, they take out the mud that is surrounded by the cookie cutter and then fill it up with cement. And that is the thing that sort of glues the structure to the bottom.
Barges extract 29,000 cubic yards of water and mud from underneath the GBS, while workers insert 100,000 tons of concrete between the skirts. As the cement dries, it glues the base to the bottom of the ocean, and the Hibernia GBS is ready to extract the first oil from the Grand Banks. The Hibernia's crew will drill over 80 wells 12,000 feet below the ocean floor. Some of those wells will extract oil. Others will pump water and gas back into the reservoir to help maintain its geological stability. Finding the oil, however, isn't as easy as it sounds.
What a puzzle you have here. You're trying to figure out what's happening 3 miles down with very little information in all reality.
Using state-of-the-art computer technology, the Hibernia reservoir team can work at record speeds. As they drill into the oil field, scientists on shore can watch in real time exactly what's happening. Analyzing the data as a team, they're able to make immediate adjustments which allow for a more productive well. This revolutionary process pays off quickly. In just 6 months, the Hibernia GBS delivers its first tanker full of oil, 1 month ahead of schedule. It's a tribute to the hard work of over 8,000 men and women all over the world who built the Hibernia GBS. It's also a victory for modern engineering over a hostile environment, tempered by an awareness of the ocean's never-ending threat.
It's a spec. We're all specs. It's a very small piece of equipment out there in the North Atlantic.
But for now, the builders of the Hibernia GBS can savor their accomplishment. The platform's success has already sparked a search for other lucrative oil reservoirs in the Grand Banks. Geologists now speak of drilling in even more remote regions, like the Arctic, long thought to be too dangerous for oil platforms. The future of the offshore oil industry rests upon this million-ton superstructure anchored in one of the deadliest oceans in the world. As it towers above the waves, the Hibernia GBS is a proud symbol of human ingenuity's triumph over nature's challenge.